is FE Approximations of Membrane Vibrations by Josh Tempelman and Tony Wente, satisfying the ME 872 final project. Our problem statement is to solve the wave equation for a rectangular domain, and on that domain we set the boundary conditions to be 0 along the edges, and we also did not have a forcing function. We took the analytic solution and solved it using separation of variables to compare it to the FEM solution later to prove that our FEM is working. We went from the strong form to the weak form, then we discretized in space, mapped it to the master element, then we discretized it in time, and then solved the problem. We found the weak form by multiplying it by some arbitrary function so that we could find U that is within the first Herbert space and is kinematically admissible. We then split the domain into the master element domain using x1 and x2 being mapped by phi1, 2, 3, and 4 in terms of psi and eta. We then use this to find our deformation gradient and our elemental stiffness matrix and our elemental mass matrices. We then discretize it in time using an explicit scheme where theta equals 0. And then we then solved it using a stability requirement where delta t was less than 2 over the maximum eigenvalue of the problem, because theta in this case was 0. We then have an example of one of the solutions here, which is the comparison with the analytic solution for the 2-2 mode. And we also have the solution for a center pluck